Hello everyone, welcome back to the second lesson in the module 7. It's adding and subtracting rational expressions. The last video was multiplying and dividing rational expressions. Now here, adding and subtracting will be quite tricky compared to multiplying and dividing. Usually adding or subtracting is easy, isn't it? But now, because it is rational expressions, we will come to see that adding and subtracting rational expressions is tougher or a little bit trickier than the multiplication or division. So the learning objectives of this lesson are simplifying rational expressions by adding and subtracting, and to simplify complex fractions. We have looked into what is complex fractions in the last lesson. We'll be adding on to it, and we will learn to add and subtract. Adding and subtracting rational expressions. Now here, let me just give you an example. This one over here, this example, a by b plus c by d. Now there are plenty of methods. The method which I will teach over here in these videos are, supposed to be easy. It's much easier because you can use that method almost everywhere. Doesn't make a difference, but it's much easier to remember in the exam as well. So now, here you can see they have taken the LCM, least common denominator, and you use the LCM method to make the fractions 1. Now, if you've forgotten how would you add them up, now these are all constants, but how would you add them up? There's a simple method. Whatever is in the denominator of the other side, see this is one fraction ratio and this is one ratio, right? So look into the denominators. We are not interested in the numerator. Numerator, fine, whatever it is. But the denominators are very important, these two denominators. Now what we need to do is, we need to make the denominator same and then we can solve it. Now, why does the denominator need to be same? Now imagine you have 2 by 5 and 1 by 5. Can you add this? Yes, the denominators are same, so 5 is the same thing, and you just add 2 plus 1, the answer would be 3 by 5. This is very straightforward. But what if the denominator 2 by 5 plus 1, let me take 2 by 10. Is this possible? No, right? You can't just write denominator as 10 or 5. What do you have to do? You have to find some common ground between these both. In the sense, you have to make sure these both are same. So one way is finding the denominator, the LCM is 10, and then multiplying this. There's a method, but now I'll tell you an easy method instead of this method, because you will find this LCM method in many places. But the easy one is, see what is the denominator over here? 10, isn't it? So you know that I can multiply and divide. If I multiply and divide the left side by 10, it does not make any change. So I'm multiplying and dividing. Why this will be 1 itself? Because it's the same number, right? So I can do that manipulation. So I'm basically multiplying and dividing both the sides. I'll be multiplying the numerator and denominator by 10. Why is this 10? Because the denominator over here is 10. But now the denominator is 50. It's not 10. It doesn't help, right? You should do the same thing. See what I did over here, it's 10, right? The same thing must be done to the other side, but not with 10, with whatever is this number. It's 5 here. So multiply here by 5. Multiply here by 5. Now let us simplify. Here, when we simplify, what do we get? We are going to get 10 times 2 is 20 divided by 50. Plus 5 times 2 is 10 divided by 50. Now 50 is a common term, right? I can write it just like this, because 5 and 5 was same here. Now 50 and 50, and it is 20 plus 10. The answer is 30 by 50. Or you can write it as 3 by 5. Only the denominators, only once the denominators are same, we can solve it up. So now coming back to this question over here, B and D are not same. So can I do the same method what I employed here? Yes, absolutely can. So let us just multiply here by D and denominator by D. But don't multiply D here. Here it will be done by B. So now when we rearrange and write, you can see that we can write this as BD or DB anyhow. BD is the denominator over here and it is AD plus here it is BC divided by BD. Or you can write it as DB anything, it's fine. I'm just writing in ascending order. It's like A, B, C, D. That's the order I've used. Now you can see here BD and BD is same. So what do? I'll just raise this up over here. So now all you can do is write the denominator, the same denominator, it's BD, and add AD plus BC. So this is the method which we will employ. Now the reason me telling this method, because this is easy, just multiply whatever is the denominator of the opposite things. Now this ratio has B, so that will go to the other side. The denominator over here is D to the other side. So other side of plus or minus. So we will employ this method and solve rational functions. I know I spent a lot of time, but if you understand this concept, whatever is done, just now whatever was done, that is it. You will easily understand rational functions to add and subtract rational expressions. Now subtraction is also the same. Look over here, the sign is the only difference. Other than that, it's almost the same. There's no difference here. So now we will solve a problem here. Now if you see the textbook, they have used the LCD, least common denominator method, and then they have found out 20B. But now what I'm going to say, it'll be a different one, but then we will have to simplify. Initially you might find, okay, it's a bit long method, but honestly speaking, the method which I would tell you will be useful in various cases, because it'll be a direct problem in most of the cases, and you can use that in all the problems, but just that there'll be a simplification part. Now let's do this. Here, now we will write it 7a by 4b and plus 4c, it's 4c squared by 10. Now what you need to do is look at the denominators. The denominator here, it's 4b, this is b, and 10. So this denominator will be multiplied up over here, 10, and down to the denominator. Now this denominator, left side denominator to the right side, it will be 4b, multiply here as well, 4b. So here you can see 4b 10 and 10 4b. That means our denominator is the same. Now all you need to do is write the same denominator. You can do this directly, you can save a step. 10 times 4 is 40b. You can write it directly instead of writing it separately. Directly it's 40b. And now what? This will become 70a. 7a times 10 is 70a plus 4 times 4 is 16bc squared. Now this is the answer, but you can see over here there are 2 is common over here. You can see 2 can be removed from 70. This can be simplified. What do I mean by simplified? Because it's all even numbers. That means 2 can be divided by all these terms. If you do in the calculator, 2 can be divided this term, this term, this term, and you will get the answer. Or you can take 2 common out from the numerator. I will repeat. The method is either you divide all these, see this is a separate term, separate term, separate term. You divide both these terms and the 40 by 2. You can simplify it that way. Or the best method would be distributive property. Here I will remove 2 outside. So what remains? It will be 35a plus 8bc squared divided by, here it is 40b. Now if I multiply this 2 here, you look over here, you can get it. 35 times 2 is 70a 8 times 2 is 16 BC square. So it's the same thing, it's just that I've removed the 2 out. Now 2 one time, 2 over here will be 20 times. So you will get the simplified form, that is 35a, that was the answer, 35a plus 8bc squared divided by 20b. This is the final answer because it's simplified here. That's it. We will look in one more problem. Now you can try pausing the video and solve it by yourselves. Okay, now what do you do here? I'll directly write it. 2x divided by 9y minus 7y by 6z. Both will be multiplied by the denominators from the opposite sides. Sorry, not the opposite, the other terms. See over here, 6z is multiplied here, 6z or z, 6z. This is 9y, up and down, 9y. And now what do we get? We will get the same denominators. Let's solve it up. We will get 9 times 6, it is 45 plus 9 would be 54. 54 y and z. So always, if you multiply the denominator of the opposite term of the next term to the other terms, you will finally land up with the same denominator. So I wrote it together at once. Now let me solve this up. 2 times 6 is 12 x and z minus 7 times 9 is easy, it's 63 y squared. So this is it. Now there's no common terms to remove over here. I believe that's the answer. Let's check. Okay, no, there is some common term. Okay, which is the common term? Oh, it's 3. Okay, I was just thinking which will go. Yeah, it's 63 because I thought 63 was, not divisible. Now here, which is a common term? 3 can be removed out, isn't it? So what you're doing is basically removing 3. This is just simplification. 3 is removed out, so you're remaining with 4xz minus, here when 3 goes it will be 21 y squared divided by 54 y and z. 3 one time and 3 8 times, sorry, 18 times. So this would be the answer. Yes, that is 4xz minus 21 y squared by 18yz. Now you might be thinking this is an easier method in this case. Now over here, I'll just tell you how to do this method anyways. See, instead of multiplying the denominator, you find the LCM. How do we find the LCM? LCD, sorry. This common denominator, that is 9, 6. These to be multiplied. Which is the number that will be divided by both of these? It's 3. And you must get a whole number when you divide, which is a multiple basically of these. So it's 3, 2. So now these are prime numbers. You stop over here, multiply. 3 times 3 is 9, 9 times 2 is 18. So 18z, 18. And what are the alphabets? You must just write them as it is because this is not same in both of them. 18yz. That is the LCD. See, this is the LCD. Now 9y is already there. What must be multiplied in order to get 18yz? This is the other method which I'm telling you. So this over here, you need to divide this by 9y and you can see it cancels out. You will have 2z. So you multiply this term by 2z. And then you need to again divide this by 6z. Now this goes, and this instead of 9 it becomes 6 and z, and that cancels out over here, and you can see it's 3y is multiplied up and down. So this is the method. Now what happens is sometimes you might be confused. Okay, it's 2z over here, 2z over here. You might be confused in this. Once you understand that, then that's fine. But the method which I'm telling you is just the denominator multiply up and down and then simplify. It will work all the time because the denominators will be the same. Only thing is you need to simplify the last step. Now, one thing, if you have done the problem correctly and your option is not there, then look at the problem and try to simplify it. That's it. It'll be simple, the method which I'm teaching you. Now let's see some problems like this. Now you'll realize its importance. So here, it's not a difficult problem. It's just that the rational fractions are bigger than over here. So you have a binomial, trinomial, and constant and a binomial again. So how do we do this? The method is the same thing. Now here you can see, oh, okay, that's split. But now what I'll do is tell you the calculator method, because we have done splitting of this, but I had put a link in the description in the last video to solve these trinomials manually without calculator. So if you're wondering how to solve this, please click on that video, and over there it's explained in detail how we can do it. But now, for now, here, for time, to save time, I'll just use the calculator method. Our goal is to simplify these terms, in the sense we can't keep it in quadratic form. We need to get it in terms of factors. Okay, we have to factor it out, factor the trinomial. That's it. The easiest method is mod phi and 3, and now you have to just put in the coefficients. That is 1, then you have 2, and lastly you have minus 15. And now you can see the factors over here. X equals 3 and x will be equal to negative 5. So in the last lesson as well, we had seen if you have to write in terms of factor, you need to change the sign and bring it inside. So what happens? 2x plus 1, okay, divided by, here it will be x minus 3 as a factor and x plus 5, because when minus 5 comes in, it'll become plus 5. Minus 7 of, over here you can see phi is common term, you can remove it out, phi, and you will have x minus 3. So this is it. So calculator is used just to factor it out. Now whatever I told you a while ago, do the same thing. Multiply this term up and down here, and then all you have to do is this denominator, phi of x minus 3, in the numerator and denominator, and these two terms here on the right side. So let us do that. So I'll just highlight the terms. This term goes to the here and here, and this term goes over here and here. I hope that's clear. Now anyways, I'll do it. It's 2x plus 1, that will be multiplied with 5 times x minus 3, divided by these two terms, the denominator, x plus 5. Now don't forget, you have to multiply the denominator even over here, 5x minus 3. Okay, that's one side. Now the same thing will be done to the other side, but the denominator of the left side, that will be 7 times x minus 3 and x plus 5. And divided by the denominator over here is already 5 of x minus 3, and you have another 2, that is again x minus 3, and lastly we have x plus 5. Now these are the terms, and now here you can see the denominator is all the same. So let's write it all together. Here this denominator is the same, right? So over here it will be 5 x minus 3. I will not write it x minus 3 whole square because it might get cancelled. Let us see now. This is again x minus 3. We get x plus 5. And over here in the numerator, the first over here I'll write 5 x minus 3. And here the next term is 2x plus 1 minus 7 of x minus 3 and x plus 5. So here all you did is you just multiplied the denominator of this over here and this. So you might think, oh, there's too much, right? It's just the denominators you have to multiply up and down. And now what are you doing? You will have to just simplify. Let's see any common terms. Yes, you can see the x minus 3 is common. You can take that common out and cancel it with the x minus 3. See, x minus 3, x minus 3, x minus 3. So other than that, everything must be there. So basically that's the answer. You can see the final answer over here. It will be Okay, you have to simplify it. Okay, let's do the simplification as well. Now this would be the answer, phi of 2x plus 1, and that would be the answer. But here you're just multiplying everything inside and simplifying as much as possible. I'll just tell you what it is. Now this is the answer, phi 2x plus 1 minus 7x plus 5 divided by this denominator, what is remaining, is the answer. But instead of writing it as phi 2x plus 1, they have multiplied it and simplified as much as possible. It makes sense because it's all terms which can be simplified. So multiply this phi here. I'll just remove this term which is all cancelled. This and this cancels off. So now you can see here it is phi, here it is 7. Now you need to multiply them inside to both the terms, and this over here to both the terms. Okay, now we will do that. It will be 5 times 2x, it will be 10x plus, the denominator is done. We are not going to do anything with it. That's it. We can't simplify it further. But this over here, it will be 10x plus 5. Now minus 7x. Now I'll put a bracket. Why? Because this minus is for the entire thing over here. Okay, 7x plus 7 5 is 35. Now divided by the denominator, phi into x minus 3, x plus 5. Now over here it's minus sign. What I'll do is I'll just multiply the minus sign. When you multiply positive 7x with minus, it'll become minus 7x, and this plus 35 with minus will be minus 35. So what happens? It'll become minus 7x minus 35. And now 10x minus 7x can be simplified, isn't it? 10x minus 7x will be 3x, and minus 35 plus 5 is minus 30, divided by this denominator, phi of x minus 3 x plus 5, and that's the simplified version. Really, this was the answer which we had got up above just by multiplying and writing the denominator, but this can be simplified in the numerator, so we just simplify it to this form. Okay, so this is the answer, 3x minus 30. Denominator is that same. Now then, we have another check problem. Please do try it by yourselves and then let's check the answer. I hope you tried, and now we will see this. Here we have 3x divided by, now here I can see 4 can be removed out. Now there is a thing about this problem. You can use, since it's square, quadratic, you can use calculator. Otherwise, oh yeah, it's better you use the calculator itself. No, let's leave it for now. Wait one second. Let's see. 4 into x square plus 1. Okay, it's x square plus 1. Why? 4 is removed out common. Now, so bracket comes and it's x square plus 1. Now minus 2x square divided by, what about this? Now, I hope you remember the formula, x square minus, sorry, it's a square minus b square. It's a square minus b square. Now, what is a square minus b square equal to? It is equal to a plus b, a minus b. Okay. Now, in this, a plus b, a minus b, the very important thing to remember is, even if it is to the power 4 and this is power 4, then you can apply it. How? Now here, instead of writing x to the power 4, I'll write it as square the whole square minus 1. I can write 1 to the power 4. It's the same thing, so it doesn't make any difference. So I'll write 1 square. Now you can see this is in terms of a square minus b square, whereas a is x square itself, then the outer square. So what I can do it is, a is x square plus 1. Here, x square minus 1. So now, why I did not remove this, I did not do any changes, because see, this will be cancelled, so that's the reason. So this can be simplified. The x to the power 4 minus 1 can be simplified and written as x square plus 1 x square minus 1. Now this cases are there plenty of times, even in the high grade, so please remember this. Whenever you see x to the power 4 and there's a number 1 can be manipulated, however, because 1 square is 1 to the power 4 is also 1, doesn't make a difference. So this would be the answer. Now the denominator over here is basically x squared plus 1, x squared minus 1. Now all you need to do is multiply the numerator and denominator by these two terms, by the denominators of the opposite sides. So it becomes, I'll just write over here, so 3x multiplied with these two terms, x squared plus 1, x squared minus 1, divided by 4x squared plus 1, again there is x squared plus 1 and x squared minus 1. I hope this is clear. This is plus 1. Now how did we get this? This is because we multiplied this denominator up and down. And now you have minus 2x squared divided by this denominator. Okay, this denominator now it'll be multiplied with, I'll just put the bracket, 4 times x squared plus 1, and here it will be x squared plus 1, x squared minus 1 multiplied with this denominator. It is 4 into x squared plus 1. So the denominator can be written same. Why? Because both the sides of the denominators are the same. Now you can write it as a whole together, and this over here we can simplify it. Now before simplifying, you can see once we write it over here, now it's the same denominator, right? This minus, so let's just what you can see over here is x squared plus 1 is there, x squared plus 1 is there, even in the denominator x squared plus 1 is there. So what you can basically do is, even if you're not simplifying, this can be cancelled up over here, here. This can be cancelled here and here. This is the extra step if you do this method where you multiply the entire denominators, but it's much easier because you will have to, there's no need of the LCM step at all. So this would be easier in a way. So only thing is the simplification is important. What happened? The denominator, I've just cancelled it off. Why? X squared plus 1 up and down. Here also x squared plus 1 up and down. Instead of taking writing the same denominator, I just cancelled over here. Now what do I have to write? I have to write 4 of x squared plus 1, x squared minus 1, and what's remaining here? I'll multiply it inside. It will be 3x multiplied by x cubed, that x squared, that will be 3x cubed minus 3x. Same thing, minus this entire thing is gone. It will be just minus 8x squared. Okay, now I can just, this is it. I can't simplify further. This is the answer because there's no common terms or anything. Just to, this is, I have written the problem as it is, just simplification. Next is just multiplying the numerator denominators, and third is the answer. Let's see the answer. It is x squared, 3x squared. Now this term is written over here in standard form. After x cube, it's written as x squared. It's just the same. 3x squared minus 8x squared minus 3x divided by 4 of x squared plus 1, x squared minus 1. This is the answer. Now I'll just recall over here if you're just getting confused. Now after we multiply the denominators to the numerator and denominator, we will get it, right? And then cancel any common terms. You can see the terms are common, so we cancelled it. And then what is done here? This 3x is a term that is multiplied here. When I multiply 3x, x squared distributive property, it will be 3x cubed and minus 3x. And here, since this is gone, you're just 2 into 4, that will be minus 2 into 4 is 8x squared. That is the answer. I hope this is clear. So now we will move on. That's the solution to real world problem. Here they have told the rate at which some oil wells pump oil in thousands of barrels given X years of pumping can be given by the equation, simplify that equation. Basically, you just simplify how much possible. So remember, whenever you add or subtract rational expressions, the denominators must be the same. So if they're not the same, just multiply these denominators to the other sides. So what I'll do is I'll do 20 multiplied by 3x squared plus 20. Now I'll write the denominators together. Why? Because I'm multiplying this over here and this over here. It's going to be the same. So it'll be x multiplied by 3x squared plus 20. This is the denominator. It's going to be the same for both. But what about this, right? This is the left side numerator plus the right side numerator. That would be 200x squared. Why? Because I have to multiply up and down with x, isn't it? So it is 200x squared. Now we have to just do simplification. That's it. So multiply this 20 inside. So 20 goes here, your distributive property. Let's multiply the x in the denominator as well inside. It'll be 20 times 3 will be 60x squared. 20 times 20 is 400 plus 400 plus 200x squared divided by 3x cube plus 20. Okay, now what do we have? We can, that's it, I guess. You can't take anything. You can just rearrange. Oh, there's one simplification which I forgot, sorry. This is 200 plus 60, 260x squared plus 400, which is divided by 3x cube plus 20. Now that would be the answer. Let's see. Yes, it's 260x squared plus 400 divided by 3x cube plus 20. Now you can see the importance. As we go on, the steps reduces if you use the method where you just multiply the numerator and denominator. The denominator with the, it's just simple, just 3 steps. It's almost the same. Now, over here, we will now deal with the complex fractions. We have dealt with complex fractions before as well. Now we will do with adding and subtracting. Now here, you must remember, whenever you simplify this, there are plenty of methods. You can use the same method what we are doing, but few things. Since it's division, the thing goes to the other side. There are few things we will see in this problem. You'll understand what I'm talking about. Now here, you can see, okay, they have done this method. Anyways, I'll write and solve it over here. Just remove that. These problems are quite lengthy. Thing is, it's better to leave them like this. Just solve the numerators separately, thinking how we solved just now. See, just these two steps, these two. Look at the denominator, multiply both the sides by denominator and this denominator here, and same thing to this denominator, the whole complex fractions denominator. I will do it. It's better to see how it is done. Now here you can see it's only 1, that means it's divided by 1, so you have to keep it in mind. If it's plus 1 only, you can always have a denominator 1. It's always having a denominator 1. If it's number 2, it's 2 divided by 1. That's the thing. Now then, let's multiply 1 up and down. It won't make any difference here. Now I'm just dealing with the numerator of the complex fraction, that is this xy plus 1. It'll be 1 by y. Wait, y will be same. Why? Because the denominator will be same. We have to multiply the denominators of the thing. So denominator 1 multiplied by 1, y. And this y will be multiplied to the right side, numerator and denominator. So it will be plus 1 into y is y, and the denominator is y. So I've written as common. This is one part. Now this whole thing divided by what? The whole thing was divided by this fraction, right? Now here, what is the denominator? Right side denominator multiply here. It will be y squared. The common denominator will be x. Y. You just have to write these two denominators together, because when you multiply, it'll be the same thing. Then now minus 1 into x is x, and over here xy. So these are the two factors. Now basically you have to do, what you have to do is you have to do multiplication. We have done this. It's division, sorry. So what happens? This term, let it be x plus y divided by y. Divided the complex fraction y squared minus x squared divided by xy. Okay. Now then, this will become multiplication, x plus y divided by y multiplied with, flip these two, whatever is then the denominator comes up. We have done this. If you're thinking how this works, please go to the previous lesson. It is all explained in detail. Now simplify how much you can. This y and this y cancels, and now write the remaining terms. It will be x into x plus y, and over here we have y squared minus x. So this is the final answer. Let's just look at the answer. Yes, it's okay. So okay, now this is the answer, but only thing is I forgot to write this distributive property. Multiply the x inside, will be x squared plus xy divided by y squared minus x. Now this method is much easier. I think so it's the same, but no, there are many steps. This is much easier. If you do that direct method, it saves a lot of time. So follow this method. Solve the numerator with a common denominator, and then the denominator with its common denominator of the complex fraction, and then from division it becomes multiplication and simplification. That's it. Let's see another problem here. Same method here. Now since 2 is having denominator of 1, see what is the denominator common? X, y only, because it's 1 here. Now this x is multiplied by 1, so it is x, minus this denominator is multiplied with 2, it's 2xy. Now this entire term divided by the complex fraction denominator. Now same thing, this is having a denominator of 1. That would mean the denominator is just 1 into y. Here multiply y up and down, it will be 2xy square minus 3 into 1, that's it. Now this part remains, x minus 2xy divided by xy, division 2xy square minus 3 divided by y. When you're dividing this term, divided by this term. Now change it, it'll be 2xy by xy multiplied with the denominator comes up, and this goes to the denominator, the numerator goes to denominator, 2xy square minus 3. Now y and y can be simplified out, and what is remaining? You are the remaining, see now this x can be removed out over here, right? X can be common out, 1 minus 2y is remaining, divided by, see now this x will cancel, so I'll write x separately, and then we are remaining with 2xy square minus 3. Now this cancels, so this is the answer, 1 minus 2y divided by 2xy square minus 3. Here, okay, the options are there. As you can see, it's 1 minus 2y divided by 2xy square minus 3. Option B is the correct answer. It's very simple simplification. Once you know this division, this is something we have studied already in the previous lesson. So only this part, the first part, is the tricky one. And now we have similar, it's just that, okay, over here, we had different LCDs. Now what happens is we will have same LCD. This is also same thing. You can use the same method. The answer will be the same. Whichever method you use, the answer will be the same. So let's try this. Now here, the above one, x, y, multiply this x over here, it will be x squared plus 2y. I hope this is clear. In the example 1, 2, 3, we went in detail. This denominator is multiplied up and down. So it will be x squared, xy, and this y is multiplied here up and down, will be 2y and xy. So this, since the denominators are same, we write it like this. Now divided by this term over here, so it is denominator will be 2xy. I'm just directly doing it 2x because I know we have to multiply these two against each other, and we are having x squared minus 2y here. and yeah, it's x squared, 2x, 2y. Yeah, now we have to just do the division. So it'll be x squared plus 2y. There is other methods to solve this, but because we have studied the method just now, so you can follow the same method here as well. The answer will be the same. Now this goes up when you multiply. Yeah, it'll be x squared plus 2y divided by xy multiplied with 2x divided by x squared minus 2y. This x cancels with this x, and now you're remaining over here with these terms. So 2 bracket x squared plus 2y divided by y into x squared minus 2y. This is the answer, but we can multiply this inside, use the distributive property and simplify further. It'll be 2x squared plus 4y divided by x squared y minus 2y squared. This is the final answer. Let's see. So okay, yeah, that's the answer. 2x squared plus 4y divided by x squared y minus 2y squared. This is it. And now the same thing over here. Please do pause the video and solve it by yourselves. I'll do it quickly. The denominator over here is a, and that's going to be a plus b squared. The denominator over here would be 2b, so it would be ab minus 2a. Just a plus b squared divided by a. Now I know this is division, this term, so I'll directly write multiplication, and the denominator of that term comes up divided by ab minus 2b. I hope this is clear. Instead of writing this divided by this, I've directly done the multiplication. So what you need to do is a plus b squared by a. This remains as it is, the numerator of the complex fraction, but the denominator of the complex fraction that has numerator and denominator, that flips, changes. See, this 2b comes up, this goes down. And now direct simplifications, basically, yeah, you can't, right? So what you do is just multiply these. It'll be 2ab, I'm just multiplying here distributive property, 2ab and plus 2b cubed divided by, this is again a multiplied here, it will be a squared b minus 2ab. So this is the answer. Let's see, there were options. It is 2ab plus 2b cubed divided by a squared b minus 2. Okay, let me just see the option over here. 2a squared, 1 second. Oh, let me just check the method. I've done some. Oh yes, look over here, I've copied it wrong. Guys, I will just go back, remove the option. See over here, it is 2a. I've written 2b divided by ab minus 2a. Instead of a, I've written b, and that's why I got the wrong answer. Please don't do the mistake which I did just now. This is a. Now a multiplied here, it will be a squared b minus 2a squared, not 2ab, it's 2a squared. That is the correct answer. And now we have the option over here. That's a, option A. Now it's intact matched. I'll just remove these over here so you can see. That's the correct answer. I had written instead of A as B. That gave me the wrong answer. I by mistakenly wrote it wrong when I was copying it over here. So make sure you write the terms properly and multiply it properly. Okay, that's the end. That's the end of addition and subtraction. It's just a bit lengthy, but it's very straightforward. Once you know what you're doing, once you get a hang of it, then it's very simple. Practice more problems, you'll be more thorough with it. So that's it for this lesson. Stay tuned, and I will come up with the next lesson very soon. Till then, bye-bye.